First question, find the derivative of that. So if you've got y equals 3 minus 2x to the power of 5, we wish to find the derivative. dy dx is, using chain rule, it's been 2 weeks, I don't know if you remember anything, I'm hoping we do. 5 goes to the front, 3 minus 2x, take 1 away, that becomes 4, multiply by the derivative inside, negative 2. Okay? Chain. That means the derivative is negative 10, 3 minus 2x to the power of 4. That's part A, if you want to call that. Okay? Part A, we just found the derivative. It's now saying, hence, find me the antiderivative of this. Well, before I even look at that, I start with the answer that I got. Okay? Now, if I differentiate this to get that, obviously, it should be obvious, that if I anti-differentiate this, I should go back to that. True? If I took 1 step forward, I turn around and I take 1 step back, I'm going to come back to where I started. So, I write this, squiggle, negative 10, 3 minus 2x to the 4 dx. That's the formal way of writing antiderivatives. I'm saying to you, if I anti-differentiate this, I know the answer will be 3 minus 2x to the power of 5 plus 7. Make sense? If you derive x to come up with y and you anti-differentiate y, you must come back to where you started, x. Cool? So that's your first thing. Then you start looking at what the question is. The question is, they want to anti-differentiate this. So I'm looking at what I know, and I'm looking at what I want, and say, well, how the hell do I do that? What's the connection between those two?
Have the same power.
Same power, so that's good. Bracket's good. So I'm happy with this. Happy with that. The only thing that's a bit out or doesn't look good is the coefficient. Yeah? Beautiful. As long as the x bit's good, you can always adjust the coefficient. Right? So, carrying on from that, this could also be written like that. True? So I've looked at what I'm wanting. I want the 5 stuff to be inside the squiggle. That's what I'm trying to anti-differentiate. Yeah? So the difference between that and that is the factor of negative 2. Equals, I know the answer. So, go back. I've looked at, straight out one, I've looked at the question. I want that question of mine to be inside the integral. This is what I'm trying to achieve. I'm trying to achieve the antiderivative of this. I've written that in comparison to this. Let's take the negative 2 out. True? Therefore, what I'm trying to get is equal to, what am I going to do? I just want the squiggle bar by itself. Get rid of the negative 2. How? Divide. So if the antiderivative of this is that, then the antiderivative of that bit is negative a half of that, because that's the adjustment factor between the two. Digested?